Hello everybody. We're going to go through a quick inheritance demo. So if you remember, inheritance is one of those programming features where we discuss an is-a relationship. Anytime we can grammatically or logically put the words is-a between two objects, then we have what we call an inheritance relationship. A relationship may be something like this, where a student is a person, okay? Or a square is a rectangle. When we put those is's between it, what we get is this subclass superclass relationship. So student being the subclass, person being the superclass. And what that essentially means is I can code things up in the superclass, and the subclass inherits those things that I code in the superclass. And what I mean simply by that is that it gets all the existing features. So once I code out a person to have a name and a gender and an age, a student will also have a name, a gender, and an age without me having to do much with it. As soon as I code something out like person, like greet, or socially distance, or whatever you want to say in a person, a student already has the ability to do that. A rectangle would be the same basic idea. If it has a length and a width, so does a square. It has a length and a width. If it has an option to get the area of itself, so does a square. If it knows how to get its perimeter, so does a square. They may need to do it a little bit differently, but they all have the basic definition, and we can always override things and get things a little bit more complicated, but that's essentially where it is. Sometimes they're pretty literal, sometimes they're not. We can go with something like this. A cylinder is a circle. Now, that may not sound as appropriate as a square is a rectangle, but if you really think about it, mathematically speaking, a cylinder is nothing more than a bunch of circles stacked on top of each other. So it does logically make sense. They share a lot of the same attributes, like a circle has a radius, so does a cylinder. They also share some of the same features, like the ability to get the area of them, although they may do it differently. We can still get the area of a circle and a cylinder. We can get the volume of a cylinder, can't necessarily do that with a circle, okay? So the cylinder does become a little bit more specific, just like a square or student could be. So the whole idea is that we come up with something generic, and then we build something more specific based upon it. The generic piece being the superclass, circle, the more specific piece being the cylinder. So let's actually code this example up here. A cylinder is a circle, and we'll see what we can do. So I'm going to make a new Python file here. First, I'm going to start with circle. All right. And again, we're going to start with constructors and our class definition. So I'm going to go class circle, which is an object to begin with. All right. And this is simply going to build a circle. And what we're going to have here is our constructor. Remember, constructors are always def underscore underscore init. Okay. And what I want to pass into this circle is a radius. Okay. And that's probably it. So what I'm going to do is come up with my attributes. So self dot radius equals radius. So remember, this radius here, notice how it just stopped turning gray, is because we passed it in. We're passing it in by argument, and it's being thrown in here, and then it's getting set into the attribute self.radius, which allows me to use it elsewhere. Okay, that's all the attributes that I want. If there were more, I'd put them in there, but the constructor in our case is done for the circle. What I like to do is make a couple methods, like def maybe get area. Again, the keyword self's going to be in there, which gives me the ability to use anything that has the keyword self attached to it, like radius. Okay, and the area method, what I'd simply like it to do is return the area of the circle. So if you remember, the area of a circle is pi, or 3.14, times the radius squared. So what we want to do is go with return, or we could say area equals, we'll just do a simple 3.14 for pi times self.radius times self.radius. Or we'll go star star 2 to square something. Okay? And then we can return the area. Okay? Same thing with circumference. Circumference is pi times the diameter, or 3.14 times the diameter. So we can go def get circumference. Okay. And we could let the return statement work for us as well. We don't need that local variable for circumference. We can say 3.14 times self.radius times 2. Okay, so self.radius times 2 makes diameter times 3.14. We get the circumference. Okay, let me make a test file here as well to kind of test this out. Okay, and in this test file we'll import what we have. So I'm going to say from circle, whoops, not AppleScript, import star. And I'm simply going to build a circle and then do certain things with it. So first thing I'm going to do is I'm going to say my circle equals a circle. All right, remember a circle I need to pass in a radius. Let's say the radius is 10. Keep it simple. All right, and what I want to do is just get the area and the circumference and print those things out. So I might say my circle area equals my circle dot get area. And that'll allow me to get it, and then I can print it out, or I can go my circle circumference and if you recall, since these were object methods, they had that keyword self in them, I have to first create an object or an instance of the class to use them, and then I have to call the methods from that one instance. So I can make several instances and have different areas and circumferences, but right now I've just got the one. And so let's just do a quick print of my circle area. So we'll say area dot format my circle area, and we'll do essentially the same thing with here, print circumference dot format my circumference. All right, let's run it, see what happens. So we'll run the test, and you can see down here the area is 314. Making it 10 kind of made it easy instead of using the actual pi 3.14. And the circumference is essentially fairly simple as well. 3.14 times diameter, 62.8 units, whatever it may be. So there's the basics there for my first class, but what I'd like to do now is create that other piece instead of it just being a circle, but also creating class, say, cylinder. So I'll actually make this one in the same file, which is a circle. Okay, and what I'm going to do here is I'm going to build my cylinder. Okay, as if it was a circle. So I'm going to go def init. Okay. Now what I need to do for a cylinder is I need to know a radius. So when I construct one, I need to tell it what the radius is going to be, and I also need to tell it what the height is going to be. Okay, and so now here's the deal. Since I'm building this in the essence of a circle, I need to send any information a circle needs to it. Okay, so a circle needs a radius, so I got to send that information to it. So what I'm going to do is go super, okay, and this stuff is completely unnecessary, but you'll notice PyCharm kind of throws it in, and it calls the init method explicitly, and what I need to do is send the radius up to it. So I'm going to take the radius that got passed in by parameter and send it directly up to the superclass constructor. Okay, so this is a call to the superclass, this is a call to the constructor of the superclass. Then I'm going to make an attribute called height. I'm going to set it equal to height, and now I have a cylinder. Okay, so there's not much to it, but what you can see is that now I can start making some other methods that will work in its stead, like a cylinder has the ability to do a volume. And essentially what the volume is the area of the circle at the bottom times the height of the entire cylinder. So let's do that. We'll go def get volume. Okay. And what I'm going to do here is return, okay, the area of the circle at the base times the height of the entire thing. So what I can do here is, let's call this volume equals. I'm going to go super, right? Get, nope, wrong one. Super dot, and then you could see I can say get area. And what that'll do is use the get area method from the superclass. I've got a get area method, it works perfectly, might as well use it. And all I want to do is multiply this by the height, or self.height, sorry. And that will give me my volume, and I can now simply return the volume. Okay, so let's come over and we'll test it. Okay, so now I've got this circle, it printed the area and the circumference of it. I'm just going to comment this stuff out for a sec. Oops, wrong button. Okay, I'm going to make a cylinder. Okay, I'm going to pass it in a radius, 10. I'm passing in a height, we'll call it 12. Okay, and what I'm going to do is calculate a lot of the things that I had before and just see what happens. So essentially what I can say here is, if you remember, I had 3.1 or 314 for the area. I can actually call that same area function. So I can go my cylinder. We'll just do a quick print statement. We'll go area dot format my cylinder dot get area. Notice it's already there for me and I can use it. Now if I do that, since I didn't recode the get area method in the cylinder class, it's going to use the get area method from the circle class. So let's see, we should get 314 for my cylinder as well. Perfect, I did. I could even do a get circumference and do basically the same line that I have here. So we'll just do a little copy paste. But instead of doing my circumference, we'll do my cylinder dot get circumference. Right? We'll run it. We should come up with the same 62.8 that it was before. So again, you can see the reusability here. I'm reusing code from the other piece, but now I can also get the volume. My cylinder. And now if I do that, I'll actually get the volume of the whole cylinder, 3,768.0 units. Okay, so there's a quick demo kind of on inheritance. We could also, if we don't like the area problem being done the way that we want, we could also utilize an area formula for a cylinder specifically. We'd have to go and look that up real quick. So let's go and check out Google. Of a cylinder. And so if we look at that, we know it's 2 times pi times radius times height plus 2 times pi r squared. So let's see if we can implement that formula into our little piece here as well. So let's see what we can do. Let's change this def get area. And what I'm looking to do is override this method. So notice the little up arrow. So I'm taking that method and changing it a little bit. So let's scroll over and see what we need to do. 2 pi, we're using 3.14 times radius times height. So let's code that. So we'll return 2 times pi times radius times height okay, plus 2 times pi times r squared. Well, the pi times r squared is actually the area of the circles, and 2 because there's 2 of them, one on top and one on bottom. So let's do this, plus 2 times super, okay, dot get area. I'm going to clean this up, I'm going to get rid of that. And what this is going to do is call that get area method from the superclass again, which we know is 3.14 times self.radius times 2. So that seems to be, star 2. So that seems to be working pretty well. And so now if I go and actually run this test class again, the area method's going to do something a little different. It's not going to get the area of the circle. It's going to get the area of the cylinder, which is going to be much larger. Okay, so let's run it and see what happens. Oops. I spelled height wrong. So let's try that again. We'll run the test. And you notice it's a lot bigger, but it is correct because now we've got not only the one circle, but we've got two of them, top and bottom, plus the area of that rectangular piece that wraps around the two circles. So that works pretty well. Now, one quick thing is if I was to bring this code back and create that circle, right? Let me just put in a quick print like this. Whoops. I'll just throw in a couple stars and /n/n just to separate a few things. Now I can do a circle. I can also do my cylinder. They don't hurt anything. So here is my circle stuff, the area and circumference of my circle. Here's the area of my cylinder, the circumference of my cylinder. And since we didn't change that circumference formula whatsoever, it still spits out the same info. And here's my volume. So there's a quick demo on inheritance. The idea that we can build something simple and then build something more specific and still use a lot of that same code. So it gives us that reusability. So I hope this kind of helps with your understanding of inheritance. I didn't mean for it to be very long. I wanted it to be a quick demo on something really simple. If we've got more questions or anything like that, feel free to reach out to me and I'd be happy to answer any of those questions. So take it, do what you can with it, and we'll be talking. Thank you. Bye.